one. Okay, so when we are looking at this first one, what we are talking about, what our video was about, was functions, right? So if we are filling in our first vocabulary, we should put a function is a relation between the input and an output. A function, there is only one possible outcome for each input. If we list all the possible inputs, in the video they talked about this word, that's our domain. And if we list all possible outcomes, does anyone remember it from the video? It is the range. Now, when we are looking at the domain and range, inputs, the variable that we used with that was our x values, okay? Our range was often our y values. I want you to make a table up here, and the first table is going to be a function, okay? And the second table is going to not be a function. So I'm going to give you two tables because in your homework you're going to be looking not so much at today's homework, but later this week where I'll be asking you, is it a function or not? So this one will be not a function. So it's going to be an XY table for each that we are looking at. So similarly when you are thinking about your test, when we have our function, we're going to go with 0, 1, 2, 3. Then we're going to have 2, and then we're going to have the number 8. Over on this one, we're going to go 0, 1, 2, 3, 2, and we'll do 8 also. So in the first one, when it's a function, what's going to happen is when we look at our domain and range, our domain is x, our range is y. If it is a function, we might have numbers something like 3 with 0. We might have 5, 1 with 5. 2 is 7. 3 might be 9. And if I have 2, I might see the same number 7. And then at 8, I might see a 7. Now, this one is a function because each input, I have the number 2 twice, right? But what is the output for it? They're both 7s. Does it matter that 8 is 7 also? No. It's just that 2 has to be the same number. So if this would be a different number, like over here, you're going to see I'm going to have the numbers 3, 5, 7, 9, and then I'm going to have another 11, and then I'm going to have 8 being 11. This one is not a function because when I look at 2, I get 11, and I input 2, I get 7. That makes it not a function. 2 does not give me, when I put in the number, I do not get a unique outcome. For each input, I have to get one output. This one had 2 of them, okay? So we are now going to take a look down in your notes at that second page on the bottom of the first page there. And as we take a look at these, and if you've ever been to a Redbox, right, you've rented movies there. So it says this DVD vending machine has input code and an output DVD that you pick up at the bottom. So we put in our code up here, you put your money in, or you put your credit card and you push in. So what if we pick B3, what movie are we getting? Wizard of Oz, right? So we're going to get Wizard of Oz. That's going to be our first one that we are looking at, right? That DVD. It says, will we always get the same movie if we push B3? Yeah, we're not going to get a different one, right? We're not going to get Raiders of the Lost Ark, right? We are always going to get that same one, okay? So it says, does this machine behave like a function? For each input, is there one output? We would say, yes. Each input, there's exactly one output. So if I asked you for the domain, those would be my inputs. One domain, part of my domain would be what? We're going to make a list. What would one of them be? A1, then I have to have A2 and A3, and B1, and can I have A4? No. There's no A4 button, right? So when we're making a list of our domain, it is simply the input. So that should be a pretty easy list. Just list all 9 of them, please. Okay? List all 9. Make sure you write that down. All 9. Okay? A1, A2, A3, B1. Does it matter what order I list them? No. You could have done A1, B1, C1, A2, right? But we just want to make sure we list all 9. And then it says, well, what's the range? The range are the movie names. So one I could put down is Gone with the Breeze. Could I put Godfather? Yes. Could I put Raiders of the Lost Ark? Yes. Do I have to have 9 names for movies? Would I actually have 9 names?
No.
No, we only have 1, 2, 3, 4, 5. We actually only have 6 movies, right, in our list. There's only 6 movies in our list. I listed 3 of them. Could you have listed all 6 of them? Sure. So what is the range of the function? We put down the names. You could have listed a couple more with that. Okay. 1, we get apple juice. We push 2, we get orange. 3, we get fruit punch. 4, we get water. Does this machine behave like a function? If I go back up and I push 1, I'm hoping to get apple juice. Have you ever been at like a hotel where you stayed and you thought you're getting apple juice and out comes orange juice? That is not a function. This one is a function, right? If I always push the right number, I should get the kind of juice that I want. So yes, every input has exactly 1 output. Now, if those people switched around, right, and gave you a different juice, then obviously it's not a function, but that's question 2 says, in a restaurant, there's a machine where you put in a quarter, you pull a lever, anywhere from 0 to 10 quarters will come out as your winnings. Sometimes you get many quarters, 6, 7, 8, 9, 10 quarters. Other times you get 1 quarter. Other times you get nothing. Does it behave like a function? No. Every time I put in a quarter, I do not get the same output, right? So no. When you put in a quarter, there are various outcomes, not exactly 1. So, thinking about what that function is, right? The last one says you have a soda machine. Push 1 for Coke, push 2 for Coke, 3 for Diet Coke, 4 for Sprite. Does it behave like a function? Does each input give us 1 output? Yes. Even though 1 and 2 both give you a Coke, every time you hit 1 or 2, you're still going to get a Coke. Why might they have that? Because people maybe like Coke more than Diet Coke and Sprite, right? So when you're looking at these answers, putting down this yes, because every input there is exactly 1 output. It doesn't matter that 2 and 1 have the same output, right? It doesn't matter that 2 of our inputs, both 1 and 2, have the same output of getting a Coca-Cola for a pop, right? So what we are going to be looking at is more like what that function machine did. So I'll make sure you have this written. As we look at our table, input, let's put X. That's also called our domain. So if I asked you what were the domains, 0, 1, 2, 3, 4, right? If I asked you what was your range, the range would be the same as our output, 0, 2, 4, 6, 8. Does this represent a function? Each input have 1 output. Yeah. What is our rule? Now when we write our rule, you are trying to see what happens to the input to get the output. 3 to get 6, 2 to get 4, 1 to get 2, 0 to get 0. Juliana, what are we thinking? Y equals? It doubles itself. So y equals 2 times the x value, right? You might see this written as the output equals 2 times the input, but usually we're going to keep them like our equations like the last unit. Now, if we look up here on your test, when we took our test, right, if x is 0, y is 0, this is called our special thing from the last unit. Remember, my y-intercept would have been b equals 0. Agreed? Okay. The other thing from our last unit, when we find slope, the change in y divided by change in x. How is my output changing each time, Zach, as I'm going down? From 0 to 2, 2 to 4. No, just think if I go from 0 to 2, 2 to get 4, 4 to get 6, what is my continual number that I'm adding on to adding 2. As I am looking, Riley, at my input values, right, my x, how is it changing from 0 to 1, 1 to change in x? Adding 1. If I have 2 over 1, isn't that the same slope here as m equals 2, right? So this is kind of my y equals mx plus b, where my m was 2. What was my b value? 0. Isn't this the same equation, y equals 2x plus 0, the same as y equals 2x? So I'm okay in your homework that you write it this way if you notice the pattern. But sometimes you're given that y-intercept is a weird number, and you'll see that as we do the next couple on the next page. So this page, this activity, I'll put this page up again when you're done. This is where I'm having you go to your computer. So this is the, it's a resource that we have. It's called Open Up Resources. So this is the textbook that's 6th and 7th graders use. It's an online stuff. So it says, guess my rule. What you're going to do is you're going to go to this web page, and then it's the second one down, and I'm just going to show you what that looks like when I do it here. But you'll put in this web address here, and when you put this in, what it's going to do is going to take you to the 8th grade Open Up Resources. And when you look at this, it says, oh, the first lesson's on dividing by 0, which we know division by 0 is what? Undefined, not 0. But then you go down and you see this guess my rule. And what you're going to do is you can put in, you can try it a bunch of times. You can put in many numbers. So if we put in 1 and we click go, it gives us 0.5. So I go back here and I go, I don't want 1. This time I want to put in 5. And for some reason, when I'm putting it in on my computer, it keeps like not letting me get the box. So hopefully yours will work better for you. Most people have been able to do it, but every time I do it on this one, I think it's because of my computer screen. But so you're going to do this, and then after you've done it a few times, you're going to ask it to reset this with a new rule. And I'll show you this in a minute. But we're going to finish going through our notes right now. So we have this last page of notes, and then your homework is, most people it's gone really fast, and then they've gone to that page where to open to Dreambox. So it says, write a rule for each function. Put your answer in slope-intercept form. Oh, that means I want my answer to be y equals mx plus b, if possible. Write that at the top. That is slope-intercept form. Use y for the output. So above all of these outputs, please put the letter y. Oh, down here it is. So my out, or output, is y. And my x is the input. So I'm going to have above each x the input. Remember, this is our slope. This is our y-intercept. First thing in this first one, from 5 to get to 9, 9 to get to 13, 14. This is not a nice list of numbers, right? They don't go in order. So look at what happens to your x to get 47 to get 51, 45 to get 49. Anyone see what we are maybe adding on to the x? Catherine, you see it? 4. Adding 4. So y equals x plus 4. These are not nice lists either in this next one going across and this first one down. I want you to look at these two and try these two, and then we're going to do the last one together. So 35, 21.
I have the other one.
You have this one down here?
Yeah.
What did you get for this one?
I put y equals x times 6.
Yes, and we're going to write it instead of x times 6 as 6x. We're going to always put our slope. So remember we talked about slope-intercept form. So we're going to put our rate of change. Is that the right rate of change? I just want you to look at this one. If we were looking at the slope m, okay, so we said that m is always the change in y divided by change in x. Now this is where I had some people going 42 minus 18. What is 42 minus 18? Take out your calculator if you need to. 42 minus 18 over 3 minus, right, so 42. I have to go with 7 minus 3. You see why I can't go 3 minus 7? Okay, I got to make sure these two are the same. So 42 minus 18, what did we get? 7 minus 3 is 4. 42 minus 18 is 24. And if I divide 24 by 4, Don't I get m equals 6? So someone said, so the change is 24. No, the change is 24 divided by 4, which comes out to equal 6. Okay? You don't want to use that change in y, change of x when you have a really weird list, but you want to use it when you have a nice list going 0, 1, 2, 3. Okay? So this one, did anyone find out my pattern for this one? Betsy got it?
Y equals x minus 14.
Always minusing 14. And if you weren't sure, check. 55 minus 41, oh, that equals 14. 48 minus 31, oh, that equals 14. And you could check all of them, and it has to work for all the numbers in our pattern. So, some of them are as simple as adding or subtracting something. Some of them are going to be multiplication. They might be division, like dividing by 3, you could write this way, or you could write it out this way. I'd take it either way. But this one, nice list. What I mean by a nice list is these numbers jump all around, right, in those first 3. This one goes in order, 0, 1, 2, 3. So I know this is called my what at 0, negative 18. That's a special number from the last unit. It's my what? Y what? Y-intercept. So this is my y-intercept. Anytime I have x equals a number, when x is 0 in my table, this number means that b equals negative 18. So I get that. Now I want to find my slope. M equals change in y. And Lee, how is my y changing each time? We're adding on how much? 18 to negative 18 to get to negative 13. Negative 13 to get to negative 8. We're adding 5. So I have a plus 5, right? Then, as I'm looking at it, Haley, how could we say our x is changing from 0 to 1, 1 to 2, adding 1? So this slope, m equals 5. So I need to write an equation. Fauna, you ready to write the equation? Y equals, we're going to go 5x instead of x times 5. 5x plus what? My y-intercept. Plus negative 18 or minus 18, right? So this one's a little different. So always writing our equations in y equals mx plus b. If I check this one, do you think my slope comes out to be 1? If I did change of y over change of x. We're not going to look at that one, but I think in my notes on the daily planner, I did that one in the other class instead of this one. Okay, so when you take a look at those. So here's your homework. So please take a look on page 24 and 25.